Geography is a field of science devoted to the study of the lands, the features, the inhabitants, and the phenomena of Earth. The first person to use the word gamma epsilon omega gamma rho alpha phi iota alpha was Eratosthenes. 4 Historical traditions in geographical research are spatial analysis of the natural and the human phenomena, area studies, study of the human-land relationship, and research in the earth sciences. Nonetheless, modern geography is an all-encompassing discipline that foremost seeks to understand the earth and all of its human and natural complexities, not merely where objects are, but how they have changed and come to be. Geography has been called the world discipline, and the bridge between the human and the physical science. Geography is divided into 2 main branches: human geography and physical geography. Introduction. Traditionally, geographers have been viewed the same way as cartographers and people who study place names and numbers. Although many geographers are trained in toponymy and cartology, this is not the main preoccupation. Geographers study the space and the temporal database distribution of phenomena, processes, and features, as well as the interaction of humans and their environment. Because space and place affect a variety of topics, such as economics, health, climate, plants and animals, geography is highly interdisciplinary. The interdisciplinary nature of the geographical approach depends on an attentiveness to the relationship between physical and human phenomena and its spatial patterns. Names of places are not geography. Know by heart a whole gazetteer full of them would not, in itself, constitute anyone a geographer. Geography has higher aims than this. It seeks to classify phenomena, to compare, to generalize, to ascend from effects to causes, and, in doing so, to trace out the laws of nature and to mark their influences upon man. This is a description of the world, that is geography. In a word, geography is a science, a thing not of mere names but of argument and reason, of cause and effect. Just as all phenomena exist in time and thus have a history, they also exist in space and have a geography. Geography as a discipline can be split broadly into 2 main subsidiary fields: human geography and physical geography. The former largely focuses on the built environment and how humans create, view, manage, and influence space. The latter examines the natural environment, and how organisms, climate, soil, water, and landforms produce and interact. The difference between these approaches led to a third field, environmental geography, which combines the physical and the human geography, and looks at the interactions between the environment and humans. Branches. Physical geography. Physical geography focuses on geography as an earth science. It aims to understand the physical problems and the issues of lithosphere, hydrosphere, atmosphere, pedosphere, and global flora and fauna patterns. Physical geography can be divided into many broad categories, including human geography. Human geography is a branch of geography that focuses on the study of patterns and processes that shape the human society. It encompasses the human, political, cultural, social, and economic aspects. Human geography can be divided into many broad categories, such as Various approaches to the study of human geography have also arisen through time and include behavioral geography, feminist geography, culture theory, geosophy, integrated geography. Integrated geography is the branch of geography that describes the spatial aspects of interactions between humans and the natural world. It requires an understanding of the traditional aspects of the physical and the human geography, as well as the ways that human societies conceptualize the environment. Integrated geography has emerged as a bridge between the human and the physical geography. geography, as a result of the increasing specialization of the two subfields. Furthermore, as human relationship with the environment has changed as a result of globalization and technological change, a new approach was needed to understand the changing and dynamic relationship. Examples of areas of research in the environmental geography include emergency management, environmental management, sustainability, and political ecology. Geomatics. Geomatics is a branch of geography that has emerged since the quantitative revolution in geography in the mid-1950s. Geomatics involves the use of traditional spatial techniques used in cartography and topography and their application to computers. Geomatics has become a widespread field with many other disciplines using techniques such as GIS and remote sensing. Geomatics has also led to a revitalization of some geography departments, especially in Northern America, where the subject had a declining status during the 1950s. Geomatics encompasses a large area of fields involved with spatial analysis, such as cartography, geographic information systems, remote sensing, and global positioning systems. Regional geography. Regional geography is a branch of geography which studies the regions of all sizes across the Earth. It has a prevailing descriptive character. The main aim is to understand or define the uniqueness or character of a particular region that consists of natural as well as human elements. Attention is paid also to regionalization, which covers the proper techniques of space delimitation into regions. Regional geography is also considered as a certain approach to study in geographical sciences. Related fields: urban planning, regional planning, and spatial planning use the science of geography to assist in determining how to develop the land to meet particular criteria such as safety, beauty, economic opportunities, the preservation of the built and natural heritage, and so on. The planning of towns, cities, and rural areas may be seen as applied geography. Regional science. In the 1950s, the regional science movement led by Walter Izard arose to provide a more quantitative and analytical base to geographical questions. In contrast to the descriptive tendencies of traditional geography programs, regional science comprises the body of knowledge in which the spatial dimension plays a fundamental role, such as regional economics, resource management, location theory, urban and regional planning, transport and communication, human geography, population distribution, landscape ecology, and environmental quality. Interplanetary sciences. While the discipline of geography is normally concerned with the Earth, the term can also be informally used to describe the study of other worlds, such as the planets of the solar system and even beyond. The study of systems larger than the Earth itself usually forms part of astronomy or cosmology. The study of other planets is usually called planetary science. Alternative terms such as areology have been proposed but are not widely used. Techniques. As spatial interrelationships are key to this synoptic science, maps are a key tool. Classical cartography has been joined by a more modern approach to geographical analysis, computer-based geographic information systems. In the study, geographers use four interrelated approaches. Systematic groups geographical knowledge into categories that can be explored globally. Regional examines systematic relationships between categories for a specific region or location on the planet. Descriptive simply specifies the locations of features and populations. Analytical asks why we find features and populations in a specific geographic area. Cartography. Cartography studies the representation of the Earth's surface with abstract symbols. Although other subdisciplines of geography rely on maps for presenting their analyses, the actual making of maps is abstract enough to be regarded separately. Cartography has grown from a collection of drafting techniques into an actual science. Cartographers must learn cognitive psychology and ergonomics to understand which symbols convey information about the Earth most effectively, and behavioral psychology to induce the readers of the maps to act on the information. They must learn geodesy and fairly advanced mathematics to understand how the shape of the Earth affects the distortion of map symbols projected onto a flat surface for viewing. It can be said, without much controversy, that cartography is the seed from which the larger field of geography grew. Most geographers will cite a childhood fascination with maps as an early sign they would end up in the field. Geographic information systems. Geographic information systems deal with the storage of information about the Earth for automatic retrieval by a computer, in an accurate manner appropriate to the information's purpose. In addition to all of the other subdisciplines of geography, GIS specialists must understand computer science and database systems. GIS has revolutionized the field of cartography. Nearly all mapmaking is now done with the assistance of some form of GIS software. GIS also refers to the science of using GIS software and GIS techniques to represent, analyze, and predict the spatial relationships. In this context, GIS stands for Geographic Information Science. Remote sensing. Remote sensing is the science of obtaining information about Earth features from measurements made at a distance. Remotely sensed data comes in many forms, such as satellite imagery, aerial photography, and data obtained from handheld sensors. Geographers increasingly use remotely sensed data to obtain information about the Earth's land surface, ocean, and atmosphere, because it a. supplies objective information at a variety of spatial scales, b. provides a synoptic view of the area of interest, c. allows access to distant and inaccessible sites, d. provides spectral information outside the visible portion of the electromagnetic spectrum, and e. facilitates studies of how features areas change over time. Remotely sensed data may be analyzed either independently of or in conjunction with other digital data layers. Quantitative methods. Geostatistics deal with quantitative data analysis, specifically the application of statistical methodology to the exploration of geographic phenomena. Geostatistics is used extensively in a variety of fields, including hydrology, geology, petroleum exploration, weather analysis, urban planning, logistics, and epidemiology. The mathematical basis for geostatistics derives from cluster analysis, linear discriminant analysis, and non-parametric statistical tests, and a variety of other subjects. Applications of geostatistics rely heavily on geographic information systems, particularly for the interpolation of unmeasured points. Geographers are making notable contributions to the method of quantitative techniques. Qualitative methods. Geographic qualitative methods, or ethnographical research techniques, are used by human geographers. In cultural geography there is a tradition of employing qualitative research techniques, also used in anthropology and sociology. Participant observation and in-depth interviews provide human geographers with qualitative data. History. The oldest known world maps date back to ancient Babylon from the 9th century BC. The best-known Babylonian world map, however, is the Imago Mundi of 600 BC. The map is reconstructed by Echard shows Babylon on the Euphrates, surrounded by a circular landmass showing Assyria, Urartu and several cities, in turn surrounded by a bitter river, with 7 islands arranged around it so as to form a 7-pointed star. The accompanying text mentions 7 outer regions beyond the encircling ocean. The descriptions of 5 of them have survived. In contrast to the Imago Mundi, an earlier Babylonian world map dating back to the 9th century BC depicted Babylon as being further north from the center of the world, though it is not certain what that center was supposed to represent. The ideas of Anaximander, considered by later Greek writers to be the true founder of geography, come to us through fragments quoted by his successors. Anaximander is credited with the invention of the gnomon, the simple, yet efficient Greek instrument that allowed the early measurement of latitude. Thales is also credited with the prediction of eclipses. The foundations of geography can be traced to the ancient cultures, such as the ancient, medieval, and early modern Chinese. The Greeks, who were the first to explore geography as both art and science, achieved this through cartography, philosophy, and literature, or through mathematics. There is some debate about who was the first person to assert that the Earth is spherical in shape, with the credit going either to Parmenides or Pythagoras. Anaxagoras was able to demonstrate that the profile of the Earth was circular by explaining eclipses. However, he still believed that the Earth was a flat disk, as did many of his contemporaries. One of the first estimates of the radius of the Earth was made by Eratosthenes. The first rigorous system of latitude and longitude lines is credited to Hipparchus. He employed a sexagesimal system that was derived from Babylonian mathematics. The meridians were subdivided into 360 degrees, with each degree further subdivided 60. To measure the longitude at different locations on Earth, he suggested using eclipses to determine the relative difference in time. The extensive mapping by the Romans as they explored new lands would later provide a high level of information for Ptolemy to construct detailed atlases. He extended the work of Hipparchus, using a grid system on his maps and adopting a length of 56.5 miles for a degree. For the 3rd century onwards, Chinese methods of geographical study and writing of geographical literature became much more complex than what was found in Europe at the time. Chinese geographers such as Luan Peixiu, Jia Dan, Shen Kuo, Fan Chengde, Zhou Daguan, and Zhu Zieke wrote important treatises. Yet by the 17th century, advanced ideas and methods of Western-style geography were adopted in China. During the Middle Ages, the fall of the Roman Empire led to a shift in the evolution of geography from Europe to the Islamic world. Muslim geographers such as Muhammad al-Idrisi produced detailed world maps, while other geographers such as Yaqut al-Hamawi, Abu Rayhan Biruni, Ibn Battuta, and Ibn Khaldun provided detailed accounts of their journeys and the geography of the regions they visited. Turkish geographer Mahmud al-Kashgari drew a world map on a linguistic basis, and later so did Piri Reis. Further, Islamic scholars translated and interpreted the earlier works of the Romans and the Greeks and established the House of Wisdom in Baghdad for this purpose. Abu Zayd al-Borki, originally from Bork, founded the Borki school of terrestrial mapping in Baghdad. Sa'ib, a late 10th century Muslim geographer, accompanied a book of geographical coordinates, with instructions for making a rectangular world map with equirectangular projection or cylindrical equidistant projection. Abu Rayhan Biruni first described a polar equiazimuthal equidistant projection of the celestial sphere. He was regarded as the most skilled when it came to mapping cities and measuring the distances between between them, which he did for many cities in the Middle East and the Indian subcontinent. He often combined astronomical readings and mathematical equations, in order to develop methods of pinpointing locations by recording degrees of latitude and longitude. He also developed similar techniques when it came to measuring the heights of mountains, depths of the valleys, and expanse of the horizon. He also discussed human geography and the planetary habitability of the Earth. He also calculated the latitude of Quasm using the maximum altitude of the Sun, and solved a complex geodesic equation in order to accurately compute the Earth's circumference, which were close to modern values of the Earth's circumference. His estimate of 6,339.9 kilometers for the Earth's radius was only 16.8 kilometers less than the modern value of 6,356.7 kilometers, in contrast to his predecessors, who measured the Earth's circumference by sighting the Sun simultaneously from two different locations. Al-Biruni developed a new method of using trigonometric calculations based on the angle between a plane and mountain top, which yielded more accurate measurements of the Earth's circumference, and made it possible for it to be measured by a single person from a single location. The European Age of Discovery during the 16th and the 17th centuries, where many new lands were discovered, and accounts by European explorers such as Christopher Columbus, Marco Polo, and James Cook, revived a desire for both accurate geographic detail and more solid theoretical foundations in Europe. The problem facing both explorers and geographers was finding the latitude and longitude of a geographic location. The problem of latitude was solved long ago, but that of longitude remained. Agreeing on what zero meridian should be was only part of the problem. It was left to John Harrison to solve it by inventing the chronometer H4 in 1760, and later in 1884 for the International Meridian Conference to adopt by convention the Greenwich meridian as zero meridian. The 18th and the 19th centuries were the times when geography became recognized as a discrete academic discipline, and became part of a typical university curriculum in Europe. The development of many geographic societies also occurred during the 19th century, with the foundations of the Société de Géographie in 1821, the Royal Geographical Society in 1830, Russian Geographical Society in 1845, American Geographical Society in 1851, and the National Geographic Society in 1888. The influence of Immanuel Kant, Alexander von Humboldt, Karl Ritter, and Paul Vidal de la Blache can be seen as a major turning point in geography from a philosophy to an academic subject. Over the past 2 centuries, the advancements in technology with computers have led to the development of geomatics, and new practices such as participant observation and geostatistics being incorporated into geography's portfolio of tools. In the West during the 20th century, the discipline of geography went through 4 major phases: environmental determinism, regional geography, the quantitative revolution, and critical geography. The strong interdisciplinary links between geography and the sciences of geology and botany, as well as economics, sociology and demographics, have also grown greatly, especially as a result of Earth system science that seeks to understand the world in a holistic view. Notable geographers: Eratosthenes calculated the size of the Earth. Strabo wrote Geographica, one of the first books outlining the study of geography. Ptolemy compiled Greek and Roman knowledge into the book Geographia. Al-Idrisi, author of Nuzhat al-Mushtaq. Gerardus Mercator, innovative cartographer, produced the Mercator projection. Alexander von Humboldt, considered father of modern geography, published the Cosmos and founder of the subfield biogeography. Karl Ritter, considered father of modern geography. occupied the first chair of geography at Berlin University. Arnold Henry Guyot noted the structure of glaciers and advanced understanding in glacier motion, especially in fast ice flow. William Morris Davis, father of American geography and developer of the cycle of erosion. Paul Vidal de la Blache, founder of the French School of Geopolitics and wrote The Principles of Human Geography. Sir Halford John Mackinder, co-founder of the LSE Geographical Association. Ellen Churchill Semple, she was America's first influential female geographer. Carlo Sauer, prominent cultural geographer. Walter Christoller, human geographer and inventor of central place theory. Yi Fu Tuan, Chinese-American scholar credited with starting humanistic geography as a discipline. Carl W. Butzer, an influential German-American geographer, cultural ecologist and environmental archaeologist. David Harvey, Marxist geographer and author of Theories on Spatial and Urban Geography, winner of the Water-and-Lud Prize. Edward Sawyer, noted for his work on regional development, planning and governance, along with coining the terms syncretism and post-metropolis. Michael Frank Goodchild, prominent GIS scholar and winner of the RGS Founders Medal in 2003. Doreen Massey, key scholar in the space and places of globalization and its pluralities, winner of the Water-and-Lud Prize. Nigel Thrift, originator of non-representational theory. Institutions and societies. American Geographical Society. Anton Melig Geographical Institute. Association of American Geographers. National Geographic Society. Royal Canadian Geographical Society. Royal Geographical Society. Russian Geographical Society. Royal Danish Geographical Society. Publications. African Geographical Review. Geographical Review.